Hello, and today we're going to look at igneous and metamorphic deposit processes. So igneous metamorphic processes are mainly focused around hydrothermal deposition. Metamorphic processes are things like converting one stone to another through heat and temperature. So let's start off with hydrothermal deposits first. What we find is we have igneous intrusions into local country rocks, which are like the normal sort of generally sedimentary background rocks in the local area, okay, under our crust. So here is our crust, and we've got our different layers of rock, and this is our igneous, what's called batholith. So this is an intrusion or an igneous intrusion, which means it's not reached the surface. So it's started off as liquid rock from the mantle, worked its way up, pushed its way up through the crust, and then stops and starts to cool down. Okay, and as it cools and solidifies, it heats the surrounding area. And what you find is you get a convection current as water is heated by close contact to this igneous intrusion. And this hot water finds its way up through fissures and faults in the rock until it reaches the surface. And this becomes a hydrothermal vent. And this hydrothermal vent is fed with cold water that percolates through the rocks to replace that comes up from the igneous batholith as it's heated. So as it heats, it expands and then it works its way up. So this is under very high pressure because of the weight of the rock forcing down onto it, and this means it's a very high temperature. And this hydrothermal liquid, because it's so hot, is able to dissolve minerals from surrounding rock. Now, because it's dissolving all this minerals from the surrounding rock, what it is in effect doing is concentrating it. It concentrates these minerals into this hydrothermal fluid. And because it's all in one place, this means that it becomes potential for us in the future to start exploiting it. So as our hydrothermal vent works its way up from the batholith, let's say this is our fissure that our hydrothermal vent is following to the surface. So here's our like geyser. It's going to dissolve all of these minerals into it, and we get this really concentrated solution, and it's mineral rich. So we have a mineral rich solution. And as this hydrothermal vent works its way up our vent, it will start to cool down. And as it cools down, it will cause the dissolved minerals to crystallize outer solution. And this means that you have a vein of minerals that can be later exploited. So it forms these wonderful crystals that are full of this mineral that might include some useful metals for us. And this becomes a mineral-rich vein of ore. And it will crystallize out in the order of least soluble, crystallizes first. And we call this fractional crystallization. And some of these metal ores that we can exploit that are formed in this way include things like tin, copper, lead, silver, gold, and arsenic. Okay, so they're the key metals that we need to know about. The next one then is metamorphic processes. So as material is laid down due to tectonic crust movements, which are ultimately why like continents move and form and reform. This causes the subduction, folding of rocks, and this results in increased pressure on the rocks, and it also places them deeper into the Earth's crust, which means warmer. So we have potentially, in addition to this, we can have igneous intrusions, which can heat surrounding rocks. And they are also going to apply pressure. So we end up, because of these sort of processes, with changes in the crystallized formation of the rocks, and we get things like limestone becoming marble and mudstones can become slate. Okay, so that you can see that they haven't melted, so they've not melted, but the properties of the metamorphic rock is quite different to that of the original rock, potentially. So slate is this really tough sort of material that you can split into thin layers and use as roofing tiles. Marble has this ability to take a fine polish, become very smooth, or be carved to a much greater extent, but it's still very tough. So that's the sort of metamorphic processes we look at. When I say igneous intrusions can heat the surroundings, so if this is our batholith, it's going to heat up all of the surrounding rocks, converting them into new types of rocks. Okay, so anything within this sort of boundary layer around our batholith can become metamorphic. And this is still going to be igneous. And these potentially could be our sedimentary. Okay,